Hello everyone, I made this video to cover the solution for our central limit theorem worksheet. Before I talk about the solution for this worksheet, I want to have a very quick review for central limit theorem. For central limit theorem, we have the distribution for the sample mean. X bar follow normal distribution with mean equal mu with standard deviation equal population standard deviation over square root of sample size. Mu is our population mean, sigma is our population standard deviation, n is our sample size. Central limit theorem, CLT, short for central limit theorem, it works if our sample size is larger than 30. Okay, if our sample size is larger than 30, no matter the population distribution is normal or not normal, we can always apply central limit theorem. Okay, so that is there is a tricky part for central limit theorem. So you can use this kind of a tree diagram to help you to solve the problem for central limit theorem. Once you get a central limit theorem question, at first asking yourself, is our population distribution normal or not normal? If our population distribution is not normal, and then you need to question yourself, is our sample size larger than 30 or sample size less than 30? If our sample size is larger than 30, our X bar approximate to normal. If sample size is less than 30 and our population distribution is not normal, we cannot solve the problem. We don't have enough information. So no solution for this kind of question. We don't have enough information to find the distribution for X bar. If our population distribution is normal, so no matter the sample size larger than 30 or less than 30, our X bar is a normal distribution, always normal, and perfect normal. Okay, it's not approximate to normal, it's a perfect normal. So this is the information we can get from central limit theorem. Now we can have a look at our problems. For number 1, sample size is equal 81, and for population mean, population standard deviation. We know population mean is equal this number, so we can eliminate this. We can eliminate this because we have mu X bar equal mu. So this is our formula for central limit theorem, right? So we can eliminate A, B, C. So we can only choose D. And similarly for number 2. For number 2, we have the standard deviation. We have the mean, right? We have the mean, we have the standard deviation. We have the sample size equal 25. Okay, and we are looking for the mean of the sample mean. We are looking for mu X bar. Mu X bar is equal mu. Mu is equal 98. So we can eliminate B and A, right? And we will choose from C and D. And for our standard deviation, it's equal population standard deviation. Population standard deviation equal square root of the sample size. So 10 over square root of 25, that is equal to, so we will choose C. For number 1, we choose D. For number 2, we choose C. Okay, and for number 3, the distribution of weekly salaries at a large company is right skewed. So that gives us the information our population distribution is not normal. If population distribution is normal, it should be symmetric. It cannot be skewed, right? And we have the mean equal 1000. We have the standard deviation equal this. We are looking for the probability for the sampling error. It's at most 50. Okay, so for our lecture, I remember I gave you a formula related with this. If we have the sampling error, we want to find the probability for the sampling error less than a constant. That's equivalent to the probability for x bar less than mu plus c, bigger than mu minus c. And in our lecture, I proved this part, right? So if you forget this part, you can have a look at the note for our lecture. Because we know our sampling error is less than c, now we can go back to our question very quickly. At most, we have at most 50. The sampling error something something at most 50. So C is equal 50 for number 3 for this problem. So now this question becomes the probability for X bar less than the population mean is 1000 plus C bigger than 1000 minus C is equal the probability for X bar less than 1050 bigger than 950, right? Now we can use calculator, normal, CDF, minimum, maximum, mean, and standard deviation. Minimum 950, maximum 1050. And for the mean is equal population mean. Population mean is 1000, right? And for the standard deviation is equal population standard deviation over square root of the sample size. What is our sample size? Our sample size is equal 50. We have 50 employees. So it's equal 350 over 50, square root of 50. We can input this number into our calculator to get the solution. And I got this number from my calculator, 0.6876. So we will choose C for number 3. Okay, and for number 4. For number 4 is very similar to number 3, right? We have the population distribution is J-shaped, reverse J-shaped, so that means it's not normal. And then we need to have a look at the sample size. The sample size is 80, so it's bigger than 30, so we can apply central limit theorem. And we are looking for the probability for the sampling error at most 75. So that means the value of C is 75. So I can just change a little bit. Change a little bit from my question here. So for C is equal 75. So just change this number to 75. This number to 75. This number to 75. And for our mean is equal 1000, standard deviation is equal 370. So for the answer for this question, it should be normal, CDF, minimum, maximum, mean, and standard deviation. Minimum is equal mean minus 75. So 1000 minus 75. And the maximum should be 1000 plus 75, so that is 1075. And for the mean is equal 1000. Standard deviation is equal 370 over square root of the sample size 80. So number 3, number 4, they are very, very similar. We just change the upper bound for the sampling error a little bit and just another change for the sample size and the standard deviation. So after calculation, here is the output from my calculator. 0.93 something. So we will choose B for this question. For number 5, that is the same question as our slide example, right? So we have the mean, we have the standard deviation. The mean is equal 430, standard deviation is equal 120, and our population distribution is a normal distribution. If we have one student, what is the probability for this one student have SAT score above 500? So for A, that is what is the probability for X bigger than 500? Because we only have one student, so we don't need to find X bar, right? So For one student, this student comes from the population, so the distribution for X is a normal distribution. So we just simply use normal CDF. Minimum, maximum, mean, and standard deviation. For the minimum is equal 500, maximum is equal 10 to 99, and for the mean is equal 430, standard deviation is equal 120. So that's it. Okay, and for B, what is the probability for X bar bigger than 500? We are looking for the probability for the sample mean bigger than 500. So we need to find the sampling distribution of X bar. Sampling distribution for X bar is a normal distribution, right? Because our population distribution is normal, so we don't care about the sample size. X bar is always normal. And then we need to input 4 numbers. Minimum 500, maximum 10 to 99, mean is equal population mean 430. Standard deviation is equal population standard deviation over square root of the sample size. The sample size is equal 35. So after calculation, you will find out that this is a very tiny number. It's approximately to 0.